concept in fixed income, duration. Task number 1, definition of duration. Duration of a zero coupon bond. This is the simplest one. Task number 2, duration of a coupon bond. Task number 3, Excel duration function and my VBA duration function. There are different measures to measure the risk. For example, for stocks, usually we can use standard deviation of return to measure the total risk. To measure the market risk, we use beta. The typical example is capital assets pricing model. Another measure is called value at risk. I'm going to use one video to show how to calculate value at risk. Other is credit rating, liquidity risk, firm-specific risk. Of course, we have all other measures. The risk measure for the bonds. The first most important measure is called duration. Credit rating, spread. Spread is for the default risk. Of course, we have other measures. Task number 1. What is the definition of duration? So definition is very straightforward. How long in years we have to wait to recover our initial investment? For example, if we wait for 5 years, then duration is 5. If we wait for 10 years, then duration is 10. For a zero coupon bond, its duration is the same as its maturity. D equals T. For example, we spend $800 to buy a zero coupon bond with a 2 years maturity. What are its yield to maturity and duration? We know the bond price is 800 and future value or face value is 1000 and duration or number of the period is 2. Okay, so what is yield to maturity? And it's a good idea to use a rate. So this is number of the period. Payment is 0 because this is a zero coupon bond. So this is present value. This is future value. This is a kind of error message. The reason is we enter negative present value, we should enter positive future value, or other way around. So then we simply change this one as negative. So the yield to maturity for this case is 12%. 11.8%. Again, duration is the same thing as maturity. So its duration is 2. To calculate the yield to maturity, we can use the yield function. You can, if you type yield function. However, the yield function is a little bit more complex. We have the settlement, we have the maturity. Actually, there are 2 dates, okay? Because this is 2 years. And suppose we today, then we can type equal today. So we're starting ending date, okay? And then we can add 2 dates from here, 2022, okay? To make it more comprehensive, okay? So this is maturity date, okay? Maturity date, okay? Specific date, okay? Then we can use a date function, okay? So date function, we have to enter year. So actually we retrieve year 2020 from the cell above and add 2 years here, 2 years here. So we use year. The year function, we retrieve today. Actually we got 2020 plus this is 2 years. Okay. Similarly, we use months. Okay, months, our today. So we are going to get 3, and day, and for the same cell. So actually, you see, we only add 2 yet, same starting day and the month, same ending day and the month, with only difference is 2 years. Instead of 2, suppose we have 5, so this automatically change to 5. Okay, so let's go back. Then we enter yield, year to maturity. Okay, so we can call this method 2. So yield. Okay, so this is settlement, maturity. So rate is coupon rate because this is 0 coupon bond, so it's 0. Price is how much we pay today, and redemption is principal, and frequency is annually. You see, 1 is annual, 2 is semi-annual, 4 is quarterly, so we enter 1. Then we have same result, this one, so it's 11.8%. Task number 2, duration for a coupon bond. From task number 1, we know that for a 0 coupon bond, its duration equals its maturity. For example, we have a 0 coupon bond, its maturity is 2 years. This means we have to wait for 2 years to recover our initial investment. D equals 2. Now let's look at the following statement or case. At the end of 2nd year, we will recover 50% of our initial investment. At the end of the 3rd year, we will recover the rest, i.e. another 50%. So 50% year 2 and 50% year 3. What is our duration? So let's record. At the end of the 2nd year, we will recover 50%. At the end of the 3rd year, we will recover another 50%. What is the duration of this investment? So actually, it is 2.5. It is, so duration equals W1 times T1 plus W2 times T2. So actually the duration of this project is 2.5. In the previous explanation, we just assume 2 years we recover 50%. At the end of 3rd year, we recover another 50%. So 50-50. We didn't discuss how much for the future value. So let's assume some values here. Okay. Suppose at the end of the year, we receive $1,000. Again, this has nothing to do with coupon bond or 0 coupon bond. It's just some investment. Okay. And how much we receive at end of 30 years? Some of you might think another 1,000. So actually, obviously, this is not correct. The reason is $1,000 received at end of the 2nd year is more valuable than $1,000 received at end of 3rd year because the time value of the money. So they cannot have the same values. Okay. So actually, we can calculate how much we are going to receive at the end of 3rd year has equivalent values. So let's calculate the present value. PV, we assume 10%, and now the period is 2, so this is 0, and just for 1 future cash flow, okay, it's $826.45. Okay, so we can use future value to calculate equivalent amount received at the end of 30 years. So same 10%. We have 3 periods. Payment is 0. So this is present value. We got a value of $1,100. Okay, so let's verify. So this is present value. 10% yield to maturity, 3 period, payment is 0, and 1,100 future value. Then we got the exact same result. Okay, so let's calculate the weight. So actually the weight is defined the present value of the first cash flow divided by summation of all present value. We have 2, so summation of 2. So let's fix this F4 and F4. So this is 50. The weight 2, same thing, is the present value of second cash flow divided by present value of all the cash flow. So this is W2. Here's the definition of duration. Duration is the weighted time. So D equals W1 times T1 plus W2 times T2 plus until Wn times Tn. Wi is the weight and Ti is time when the ith cash flow happens. So what is the weight? For example, W1 equals the present value of first cash flow divided by price of the bond. Here we are going to use a simple example to show how to calculate duration. Again, definition of duration is weighted time. Let's assume future value or face value is 1,000. Yield to maturity is 8% per year, compounded semi-annually. Coupon rate is 6%. The number of years to maturity is 5. The coupon payment is 2. This is mean each year investor will receive 2 coupon payment. So let's calculate the coupon payment. So coupon payment equals face value times coupon rate divided by frequency. This means the coupon payment each year is $60 and $30 every 6 months or half year. Okay, let's calculate the price. The price of the coupon bond equals the present value of all future cash flow. We know that 2 types of future cash flow. One is from coupon payment, the second one is from face value. So equals present value. The rate is 8% divided by frequency. Accordingly, the number period should be 5 times frequency. Coupon payment is coupon payment, is 30. Future value is face value. There are 3 ways to calculate duration of a bond. So let's use the same example. Face value is 1,000. Yield to maturity is 8%. Coupon rate is 6%. Number of the period, number of the years is 5 years. And the coupon payment is twice per year. Then we calculate the coupon payment. Again, coupon payment is simply face value times coupon rate divided by frequency. Then we use the present value, we calculate the price of the bond. Okay, so this is I call the method 1. So method 1. Okay, method 1 is quite tedious. However, it is quite helpful. It will help us to understand the concept of duration, because duration is weighted time. So we calculate weight, and weight times the corresponding time period, time, then summation will be our duration. Okay, because there are 5 years, twice per year, so actually we have 10 period. So we have 10 period. Okay, So this is cash flow. Okay. Cash flow starts from the first period and half a year. Okay. Again, it's coupon payment. The value is fixed for next 5 years and 10 period. Okay. For the last one, we add face value. Our principal is 1,000. Okay. Then we calculate present value. Okay. The present value equals, and so PV, and we know the rate. This is year to maturity divided by frequency. So this is for each period. Effective rate. Number the period. Because we consider each future cash flow, so payment is 0. This is 1 future cash flow. So actually, it's what is the present value of first coupon payment. So after we fixed yield to maturity and the frequency, then we can copy and paste. To double check, we can use summation. Okay. Again, price of a bond is the summation of all its discounted future cash flow, and we got the exact same result. Okay. Okay, so let's calculate weight. So this is weight for each time period. Okay. The weight will be the present value divided by summation of all the present value. Okay, we hit F4 to lock it. So this is 3%, roughly 3%. Then we copy and paste. Then we can check it. The summation, the weight should be 1. Summation of the weight should be 1. Okay. I don't like this one. Should be as numbers. So it's 1. Okay. Now we can calculate weight times T. Okay. T. Okay. So actually the double 1 times T1. Just be careful, this is half year. Okay. So this is double 1 times. So this should be half year. So it's 1 divided by frequency. So we hit F4 to lock it. Okay, so this is W1 times T1. Again, this is should be half year. Okay, then we copy and paste. So this is our duration. Okay, so our duration will be summation of all WI times TI. So our duration is 4.361 year. So let's look at the method 2. Okay, so this is method 2. So for the method 2, we applied Excel duration function. Okay, so the format is given here: equal duration, settlement date, maturity date, coupon rate, yield, frequency, and the basis. It looks very, very complex. So for the settlement date, we can assume anything. So suppose let's use today as the starting date. Okay, so we click year. So actually we are going to get 2020. So the year. Then we apply months. We apply month function. Then we apply date function. Okay, so actually we click 2020 March 31st. Okay, then we can apply date function. So date function is year, month, and date. Okay, so actually 2020 plus this is 5 years. So 5 years, then month, then date. Okay. the advantage of this way, instead that we simply type 2 dates. Okay, the advantage is if we change here like to 15, so here automatically change. So this is automatically change. So look back to year 5. Okay, so this is a duration. So duration is starting day, ending day. So this is coupon rate. So coupon 6%, year to maturity, then frequency. Then we got same result. Okay, so this is Visual Basic application called durationYan. There are 2 methods to get this VBA. If you are taking my course right now, just type .c6, enter 41 as input variables. Otherwise, you download a text file at this location. For the third way to calculate duration, we have to get the VBA code first. Okay, so type .c6. So this is all the instruction about chapter 6. 41 is related to the VBA. Okay, so you with .c6, we enter 41. Then we can get the code, VBA code. So actually the 2 functions. The function to end the function, this is main function called the durationYan. The second function I called help function. Just simply copy and paste. Then we return to Excel. So just click Developer, click Visual Basic, click Insert, click Module. Then we paste it here. Okay, we paste it here. Then we click File, close, and return to Microsoft Excel. Okay, so this is method 3. And as I mentioned, we have 2 functions. One help function, type durationYan. The first function is about function to calculate duration. Second one is help. Type help without any input. After hit enter key, then we have instructions. So this is usage equal durationYan, year to maturity, coupon rate, frequency, and how many years. It's very, very simple to use. Then we enter year to maturity, coupon rate, how many years, how many times we receive coupon, and how many years. Okay, we enter, then we have the exact same result. If you look at this function carefully, you will see the face value is not an input variable. Look here, face value is not an input variable. Okay, if we change this one to 100, many things change. However, the duration remains the same. Face value is not an input variable. After watching this short video, you can try this challenging task. What's wrong with those 2 methods to estimate the bond price? We use the same example. Face value is 1000. Yield to maturity is 8%. Coupon rate is 6%. Number of the year to maturity is 5. And the frequency of coupon payment is 2, twice per year. First, let's calculate coupon payment equals face value times coupon rate divided by frequency. So we have $30. Okay, so let's calculate correct bond price. The bond price equals present value. So this is a rate because it's compounded semi-annually, divided by 2, and now the period is 5 times 2, and payment is $30 every period. So this is face value or future value. Okay, the bond price is $918.89. Okay, so let's try this one. So this is timeline. We start from 0. Because this is semi-annual, so we enter 0.5. Okay, 0.5. Remember, when we calculate duration, okay, when we calculate duration, we need this time. So this is t. Okay. The first one is, the next column is called cash flow. It's simply the future cash flow. We know start from half a year, we are going to receive $30 coupon payment. Fix it, type, hit F4, and then we copy and paste. For the last period, we know we are going to add principal. Okay, so this is, so let's calculate present value. Okay, present value. So this is method 1. Method 1, it is not correct. Okay, so present value equals rate. So this is yield to maturity divided by 2. And now the period is half a year. And because we are looking at each cash flow, so payment is 0 and 30. Okay, 30. And before we copy and paste, we use F4 to lock these two values. Okay, yield to maturity and frequency. Then we copy. Then we calculate bond price, or I call price 2. So it's simply the summation of all the present value. Okay, so this is wrong. This is wrong. Okay, my question is why it is wrong. Okay, so let's look at the second one. Okay, second way to calculate. So this is present value. So this is present value. And because we have half a year, okay, so we are going to use, for this case, okay, we are going to yield to maturity. Okay, without divided by 2. So this is now the period, half a year. Payment is 0. So this is future value. And we got a little bit different result. Okay, different result. So let's copy and paste. Okay, so this is I called price 3. It's simply summation of all the discount all the future value. Okay, close it. Okay, so this is wrong. Again, so the task is why those two methods are not correct.